All right, pre-cal, here is your second graphing rational functions video. So we're going to go through the same exact steps we did on the last video. We're going to start with factoring, of course. So I've already got everything factored. So from this, now I will tell you on your quiz, you are going to have to factor what I have given you. So if what this would look like on your quiz would be something like this. All right, and then you will have to produce that factored form, okay? I just kept it this way for these problems so we could focus on learning how to graph them. All right, so what we are going to do next, of course, is write out our domain. So the domain is all of x such that x cannot be 2 or -1, and x is a real number. Okay, there's my domain. Once I do that, then I reduce. And so my reduced form is x over x minus 2. So my vertical asymptote is x equals 2. My horizontal asymptote, I have to look at the degree. The degree here is 1, the degree here is 1. That means that I'm going to have a ratio of leading coefficients, so y equals 1. And since there's a horizontal asymptote, there's not a slant asymptote. Okay, to find my x-intercepts, I've got to set my numerator equal to 0. Well, that's pretty easy peasy lemon squeezy. And remember, if your x-intercept is 0, your y-intercept is also 0. Don't even have to do any work for that. Okay, are there any holes? Well, there is going to be a hole at -1 and something because I was able to reduce the x plus 1. So I'm going to use my reduced function, and I'm going to substitute in the -1 in for x. So I get -1 over -3, which is positive 1/3. All right, once we get all of that information, we're ready to graph this puppy, all right? Because remember, we're going to get the other stuff, the range, the graph behavior, and the increasing, decreasing off of the graph. We're going to physically read it. Okay, so I'm going to start with my vertical asymptote at x equals 2. And I've got a y equals 1 horizontal asymptote. Okay, I've got an x and a y-intercept at 0, 0, so I know the graph's going to go through there. There's a hole at -1 and 1/3, so that is going to be about right there. So I know my graph is going to look something like that. All right? Now, unlike the other problem where we had points in another region, so we knew what was going to happen, with this one I don't have another one. So what I'm going to do is I'm going to test a point in a certain region of my graph. Let me show you what I'm talking about. From here over, I don't know if the graph lives here or if it lives here. So I am going to use a test point. I can use any test point I want. Let's just pick, I don't know, 3, okay? Because 3 is right here. All right, so let me erase that so we're not making a mess. So I'm going to choose 3 for my test point. I'm going to use my reduced version. Okay, so 3 over 3 minus 2, that would give me 3 over 1, which is 3. So that means I have an ordered pair at 3, 3. Okay, this is an indicator. Now I know where my graph's going to be. Life is good. And then I'm going to graph it just like that. Okay, now I can find my range. So from -infinity, see how the graph goes down this way? So I've got -infinity, and then it's going to be up to the y value at the hole, so 1/3. And then 1/3 up to my horizontal asymptote of 1, because there are values right in here. And then, of course, 1 to positive infinity. That's what the range is going to look like. Now we're going to look at the graph behavior. Remember, this is end behavior, so that's what I'm going to start with. As x approaches positive infinity, that's this out here, y approaches 1. As x approaches negative infinity, to the left, y still approaches 1. Now I'm going to use a different color to look at the vertical asymptote behavior. Oh, you can't see that. What was I thinking? So vertical asymptote behaviors right here and right here. Remember, x is approaching the same value, in this case the 2, but remember it's approaching 2 from different directions. So on the positive side, it's approaching 2 and going up to positive infinity. So as it approaches 2 from the positive direction, y approaches positive infinity. On this end, okay, it is approaching 2 from the negative direction, y is approaching negative infinity. That's what that's going to look like. Okay, now I'm going to talk about increasing or decreasing. Well, if you'll notice my graph from left to right, it's decreasing here and it's decreasing there as well. So it is decreasing from negative infinity to 2. Remember, we use our x values, our domain, or sorry, not our domain, but we use the x-axis for reference on decreasing. And there you go. And then this is none. Okay, we'll do the final example in the final video.